Hi everyone. So today's problem of the day is rotating the box. What is given in description? You are given an M cross n matrix of characters box grid representing a side view of a box. Each cell of the box is one of the following. What can be the values? Value can be hash. Hash is representing the stone. It can be asterisk. It is representing a stationary obstacle. And if it is a dot, it is representing an empty cells. And what is given? And the box is rotated 90-degree clockwise, causing some of the stones to fall due to gravity. Each stone fall down until it's land on an obstacle, another stone or the bottom of the box. Gravity does not affect the obstacle positions, and the inertia from the box rotation does not affect the stone horizontal positions. It is guaranteed that each stone in box grid rest on an opticals, another stone or the bottom of the box. Written in n cross m matrix representing the box after the rotation described above. So what is given in the question is like, if we will see for some example, we will be given some 2D grid and 2D grid cells will have one of these three values. It will have either hash, asterisk, or dot. Dot is representing an empty cell, empty space, and this asterisk is representing an obstacle, and hash is representing hash is representing a stone. So if you will see, this is our initial box grid in which this is stone, empty space, and this is also stone. If we will move it 90-degree clockwise, then 90-degree clockwise, if we will move, it will be something like stone. Then this is empty space, and this is also stone. But since this there is empty space, so this is stone due to gravity fall into this place, and it will be something like empty space, stone, and this is also stone. So we can return that final grade. So what basically we need to do, how we can solve this problem? First, we need to rotate by 90-degree. And if you know that to rotate by 90-degree, if our initially this is I comma j. So for the old matrix, old box grid, then after rotating it by 90-degree, our coordinate will be something like n minus I minus 1 comma j. So by using this formula, we can easily rotate our grid by 90-degree. This is our first step. And then what basically we need to do, we need to check for every columns. For every columns, we need to check if there are empty space. Then we need to shift that stone to that empty place, and like because of gravity, we need to move it down. But if you suppose there is not empty, there is stone, there is not empty string, there is one obstacle, and there is also one stone. These two are stones, and this is obstacle. So if there is obstacle, so it will this stone will not move to this cell because there is obstacle. If there is obstacle, we move the stone which is up of that obstacle. We can only shift if there is an empty space. So if you will look into the second example is something like stone, space, stone, obstacle, space and space. If we will move this 90-degree, it will be something like this is stone. This will also be stone. This is obstacle. This is empty space. This is a stone, space, obstacle, empty space. So since there is obstacle here, so we can't move this stone a bit down. Same for this stone, we can move down because there is obstacle. But if we will check for this for the first column, if we will, there is stone, there is empty space. So we can easily move this stone to down. So it will be something like stone, obstacle, empty space, stone, obstacle, and empty space. If we will check for the third example, mein, it is we are doing the same thing. There is a initial grid, and in final grid we are seeing this space, the empty space. So we are shifting this stone downward. But for second column, if you will see, there is obstacle, so we can't move this down. Same for this also, we can't move it down because there is obstacle, and we can return this after rotating it by 90 degrees. So if I will see in this constraint is it is giving something like n and m row and column can range from 1 till 500. So it is clear that in rotating that grid to 90 degree, it will not take extra space. It will take m into n time complexity only, because we need to loop we need to use two for loops. So because we need to what we have to do, new matrix ij equals to matrix old n minus n minus I minus 1 comma j, sorry, n minus j minus 1 comma I. So just we need to use this formula, and inside these two for loops, so we can after this our first step will be completed, and our grid will move to 90 degree. If our grid is moved to 90 degree, now what we need to do, we need to check if we can move a stone down if there is no obstacle. To to uh, so to do that, what we can do is we can assume one example. Suppose at this example only, this is a stone. After rotating it by 90 degree, empty space, and this is a stone. So we will traverse for this column. So for this column, we will initialize our empty space. Empty space equals to last this. So 0, 1, 2. It will be initially 2, because we will store last row value for empty space. And then we started traversing from this last row till we need to move up. So if we are at this position, so this is stone. If there is stone, if there is stone, then what we need to do? We need to swap this row with the empty row. So our empty row is 2 only, and this is 2 only. So after swapping also, it will not change anything. What we need to do? We need to swap empty row with the current row if there is stone, and we can do this empty minus minus, because we have already filled this with stone, so we will move it to we will change it to minus minus, so it will become 1. And we need to do empty minus minus also. Now this is space. If there is a space, we don't need to do anything. Again, if there is stone, so stone ko again we need to do the same thing. Swap empty row with the current. So empty row is this, and current row is this. So we will swap it with this first row. So it will be something like stone. This already stone is there, and this is empty. We after swapping, it will move here, and it will move here. So this will be our final answer. So same thing if we will try for a second example. Second example mein, first we will do with this column, and then second we will do with this column. So first if we will do with this column, so what we can do is like if there is a, firstly we need to initialize empty row equals to the last row. Last row is 0, 1, 2, 3. And now we will see if there is a space, we don't need to do anything. We just move one row up. Now there is obstacle. If there is obstacle, what we need to do? If there is obstacle, we can't change our we can't move a stone to this place. So we what we can do is we can do this empty minus minus. Now coming to this row, this is a stone. So if there is a stone, what we need to do is we need to This will not be empty minus minus. This will be empty equals to current row minus 1. So it will be current row is 2 to 2 minus 1, 1. Now if there is stone, so stone, if it is there, we need to swap empty row with the current row. So empty row is 1 and current is also 1, so it will not affect anything. Now we will move to this. So this is also empty and current are the same, so it will also not affect anything, and we can move to second row, empty minus minus also. So now if we will follow the same in this column, so if there is empty, we don't need to do anything. Now this is also again we will make it empty equals to 3 because in last. Now obstacle. So we already see if there is obstacle, we will shift our empty equals to current minus 1. So current is 2, so it will be 1. Now there is stone. So stone, so we need to swap with current and empty. So current is also 1 and empty is also 1. So it will not change the position. And we will do empty minus minus. The empty will move here. Now coming to this row space, so we don't need to do anything and we can directly return this. The same we can do here, and if you will see the solution also, I have done the same thing. Initialize my row and column. Then this new grid I have initialized. This I have changed my row will become column and my column will become row, with like previous grid row length. So if I will use two for loop, to, inside two for loop, this I am doing to to rotate my grid to 90-degree. So what I did, my new ij equals to old n minus I minus 1 and I. And if I will, after rotating it by 90-degree, what I am doing, I am traversing through every column. This I have used because I am traversing to every column from 0 to n minus 1. And after I'm in particular column, what I can do, I can initialize my empty with equals to the my last row value. Then I am using this for loop because I'm traversing from my last row till my 0th row. And any if I got any obstacle, I can do this empty equals to j minus 1, current row minus 1. And in else if condition, if my grid value is hash, that means if it is a stone, then I can swap it with the empty row, and I can do my empty minus minus. And finally, I can return my new grid. So if that's the solution, if I will see the time complexity in this case will be big of n square, because in both cases we have used for loop, two for loops, and if I will, it will not be n, it will basically be n into m, because row and column and space complexity, if you will see, I have used this 2D grid matrix, so I can use n into m. I used n into m for this also. So this is time complexity and this is space complexity. So yeah, thank you.